Hello everyone, I'm Leo. In this presentation, I will show you how to train your own large language models. Here is the overview of this presentation. First, I will give a brief introduction of what is large language model, and I will also show you what is the background information of natural language processing (NLP). Also, I will emphasize what is the transformer architecture together with GPT structure. Finally, I will show you my training data size, resources, and result. So, what is large language models? First, they are designed to understand and generate human language. Here, large means they are training on vast amount of text data, and it's also a subset of natural language processing. We can see here are several examples of large language models, like ChatGPT, like Google Bard, and also Cloud and Llama. And before we start, we have to know a little bit knowledge of NLP. The key idea here is each word in a sentence can be converted into a vector. For example, if we have a sentence, I love studying, these three words can be converted to three vectors, which is easy for mathematical calculation. But the question is, do these two love in two different sentences have the same meaning? The answer is not. So how can we handle this problem? The transformer architecture emerged. The key idea in this paper is attention is all you need. In this paper, this equation calculates the attention level of each word in a sentence, determining how much it should focus on other words to understand its context more efficiently. Okay, here is the most difficult part of this presentation. I will use a real example to show it clearly. We have a sentence, I love studying, and we assume that Q equal to K equal to V, which are three vectors. Here, QKT, we can use this to calculate the attention relationship between words in a sentence. And here dk is the dimension of the vectors. Here the dimension is 2 because the length of each vector is 2. A softmax function is used to normalize these scores to make sure the sum is 1. After that, we can multiply the attention score to itself. Remember, V is also equal to itself. After weighted sum, we have a new vector for love, which is 0.58, 0.84. The new vector of love now has a certain understanding of its context. Here is the structure of GPT-2. We can see from the bottom to the top. First, it converted text to vectors with a dimension of 768. And in the middle part, there are 12 sets of neural network modules. Each module contains the attention layer together with 3 other neural networks. Finally, it can generate the output for text prediction. So, what is the optimization problem in GPT structure? It is cross-entropy loss function. Here, Y is the real label of a word in training data set, and P is the probability of a label predicted by the model, and M is the total number of different categories. Here is the dictionary size, and this function reflects differences between training data size and the model prediction, so we have to minimize it. Here is an example of how it works. Assume that we have a dictionary for 3 words, studying, cats, and dogs. In training data size, the sentence is I love studying. So here, 1 means the ground truth for this data size is studying, and there's no cats and no dogs. In prediction, we don't have studying, we only have I love. So the model gave a prediction of different possibilities in each word in the dictionaries, which means we have 70% for studying and 20% for cats and 10% for dogs. We can use this formula to calculate the loss, which is 0.36. This is my training data size and my resources. I use the story text from Genshin Impact and Honkai Star Rail, which are popular open-world RPG game from China. And the size is 150 MB text data. The language is English together with Chinese, and we have 4 V100 GPUs for computing. We train this model for 150 hours. Here is my results. We can see that after 40,000 steps, the loss nearly stopped decreasing, which means that is enough. And we have already uploaded the model to Hugging Face. Everyone can download it.